Alright, so moving on to problem number 2. For this problem, we're going to end up using my old grandpa Euler's formula. If you don't remember what it looks like, it means F plus V equals E plus 2. We know that because of reading the question, so let's read it just to see what tells us that we're going to use that. It says a polyhedron has 14 faces, 8 of which are triangles and 6 of which are squares. And then they ask us how many vertices does the polyhedron have. So remember, faces is actually what the F stands for, and vertices is actually what the V stands for. But what about the E? Well, the E stands for edges, and it's actually the shared edges. And to get the shared edges, we take the total number of edges and we divide it by 2. And that's because if we think about this, right, if I have 2 triangles and they sit next to each other, they share an edge, right? Well, this triangle has 3 edges, this triangle has 3 edges, but my new shape doesn't have 3 edges, right? It has 1, 2, 3, 4, 5 edges. The reason for that is we have 1 plus 1, that's 2. 1 plus 1, that's another 2. And then this last edge, which used to be 2 edges, gets divided by 2 and becomes 1 edge. Becomes 1 edge because they share it. So we take the total number of edges, we divide by 2 for these solids. Okay, so 14 faces, we can just plug that in for F. They want us to find the vertices, so we know V is going to be our variable. Now we need to find the shared edges. Well, 8 of the faces are triangles. So we take the number of shapes, 8. We take the number of sides, 3. This is number of sides. And we multiply them. And that gives us 24 edges from the triangles. Over here, we have 6 of these shapes. They're squares. That's the number of sides. So that gives us another 24 edges. So to get our total edges then, we take 24 plus 24. Right, that's going to be 48. Then we divide by 2 just to account for those shared edges right here, right? Those things in the middle. And that's going to be 24 shared edges. So here our E is 24 plus 2, and this 2 is just part of that formula. So 14 plus V is 26, and at this point it just becomes algebra. Minus 14 minus 14, so V equals 12. And we could say 12 vertices if we wanted to be accurate. Alright, so let's flip this over. Go to the next page. Go to page 3. And here we're going to see some familiar language. They're going to ask us to describe the effect of change. Whenever we see that idea of change, we know we're just talking about how is the surface area or the volume going to change based on a change in dimensions. Okay, change in dimensions. So when we take the change in surface area, we take the change in dimensions, the thing we multiply, and we square it. When we do the change in volume, we take that same thing and we cube it. Okay. And the last part to this is that they ask us to describe. So we're going to see our answer in this form. The surface area will be multiplied by something, and the volume will be multiplied by something. All right, that's going to be the way we see our answer. We can expect that. So here's the deal. We take the number we're multiplying by. So if we're doubling, we're timesing by 2. And to find the change in surface area, we would take 2 and square it. That'd be 4. So we would write the surface area will be multiplied by 4. And then to find the change in volume, we take that same 2 and we cube it. And our answer would be the volume will be multiplied by 8. And remember, this 2 cubed, this is 2 times 2 times 2. So 2 times 2 is 4, times another 2 is 8. So over here on B, if the dimensions are tripled, we're timesing by 3. So to find the change in surface area, we do 3 squared, which is 9, and for volume, 3 cubed, which is 27. And our answer would be the surface area will be multiplied by 9, and the volume will be multiplied by 27. That would be our final answer. And then looking at C, the dimensions are multiplied by 1/4. So we take that 1/4, we square it. And when we're doing this with fractions, we can just think of this as squaring the top and squaring the bottom. So 1 times 1 is 1 over 16. And so over here, 1/4 cubed is 1/4 times 1/4 times 1/4. Or 1 cubed over 4 cubed. Right? So we can think of this as 1 cubed, the numerator cubed, over 4 cubed. But either way, that's going to give us 1 over 64. So now if we want to find the midpoint and the distance, we need to remember that these coordinates, these threefold coordinates, are x, y, and z. So to find the midpoint, we're going to use kind of this idea of averaging the two points. So x1 plus x2 over 2, y1 plus y2 over 2, and z1 plus z2 over 2. And then to find the distance, we're almost going to do the opposite, but it looks just like the old distance formula, which is the square root of x2 minus x1 squared plus squared plus y1 squared. Now we're just going to plug